Structure of water. As we know, water is made of two hydrogens bonded to one oxygen. When oxygen pulls the shared electrons closer to itself, the molecule it becomes like not balanced, right? This uneven like let's say dispersion of electrons is the starting point for a lot of water's behaviors and so on. Hydrogen bonding. So because let's say, oh yeah, because water molecules have slight positive and negative like ends, they attract each other. And these attractions are called hydrogen bonds. They're not as strong as real chemical bonds, but they're strong enough to hold water molecules together tightly. Geometry of water. The water molecule isn't straight, it's bent. And the oxygen has two lone pairs, right, that push the hydrogens down. And that creates a bond angle of about 104.5 degrees. And by the way, this bent shape is like this bent shape, how it's like going down and like that. It's is the reason of why water ends up being polar. So yeah, that was a fact. Polarity. So let's say, oh yeah, so since oxygen pulls harder on electrons and the molecule is bent, one side becomes negative and positive, like slightly negative and slightly positive. And this polarity lets water interact with ions and other polar molecules really good and really well. High boiling point and melting point. So, water needs a lot of energy to break its hydrogen bonds. That's why it doesn't boil or melt easily compared to other small molecules. High specific heat capacity. Water can absorb a lot of heat before its temperature rises. The hydrogen bonds soak up energy, right? And that slows down temperature changes. And this is why water helps stabilize climates and body temperature. Surface tension. Um, at the surface of the water molecules pull strongly on each other, and that creates a tight but elastic layer. Um, yeah, elastic layer. So that's why, for example, in the water bottle, you can see the droplets. They form like little circular beads, and that's why. And how some insects can stand on water without them sinking. It's because of the surface tension. Density anomaly. Ice is less dense than water. When water freezes, the molecules arrange themselves into a more open hexagonal structure. This takes up more space. So making ice is less dense than liquid water. That's why also ice floats. So, oh, and that's why also lakes freeze from like the bottom to like from top to down. So yeah. Solvent capabilities. Water's polarity allows it to surround and separate charged or polar particles, and it basically pulls molecules apart and keeps them spread out. So, and that which is why water dissolves so many substances. Heating curve of water. Um, Here, this graph shows how water's temperature changes as energy is added. The slanted parts show temperature rising, and the flat parts show phase changes. During those flat sections, all the energy goes into breaking bonds and not raising the temperature. Energy calculations. Here, these are the formulas of like the first one. It's Q equals mass times C times delta T. We use it for when temperature changes. And the second one is Q equals mass times delta H fusion. We use it when melting or freezing. The third one and the last one is Q equals mass times delta H evaporation. We can use it when evaporation happens or condensation happens. Here we have an example, so we can solve it. Here it says calculate energy to heat 50 grams of water from 20 Celsius to 80 Celsius. So the way that we can solve this is we have to identify what we have, right? The first thing we have is, and also the first thing mentioned is mass. So mass is 50 grams. Then let's see what we also have. We have 20 Celsius and 80 Celsius. Those are considered temperature, right? So we have initial temperature, which is let's say, oh yeah, 20 Celsius, and the final pressure, the final temperature, sorry, 80 Celsius. Then in these types of equation, we usually get the specific heat. So the specific heat is 4.18 joules. So let's start solving. First we're gonna calculate the temperature change. So the rule is delta temperature, which is T, equals initial temperature minus no, sorry, final temperature minus initial temperature. So let's substitute. We don't have the delta T, so the final temperature is 80 minus 20, which is 60. C. Now we got the temperature change. Now let's put it into the formula. The formula that we're gonna use is temperature change, which is the first one. Just gonna erase this so we can have space. Okay. Now let's write we have Q equals, we have the mass, which is 50. We have the C times 4.18 times 60. Just like that. So the first ones, we're gonna multiply the mass by the specific heat, which is 50 times 4.18, which is 209. Then we're gonna multiply 209 by 60, which is gonna give us 12,540. And that's it. We just solved it. It was pretty easy. And yeah. And that's it. Thank you. Hope you enjoyed. Bye.